Again. This time we are going to be talking about the sun. This is not going to be nearly as long, so I promise. Okay, part of my slideshow didn't realize. Okay, there we go. Minor default, but here we go. All right, so the sun. The faster speed that made this video go a little bit faster as well. But the structure of the sun, and I'm going to find a spot, where I can actually hang out and stop moving myself all around. But the sun has an interior, so it has interior layers, and then it also has atmospheric layers. And there's 3 layers to the interior, and that's going to include the core, which is it, and then you have what we call the radiation zone, and then you have what we those 3 layers in the interior, and then you have 3 layers in the atmosphere, which are going to include the photosphere, the chromosphere, and the corona. Isn't that funny? This lovely coronavirus, and now we're talking about the corona. Little bit. And then, so as you move, like it says down here, layers of the atmosphere become less dense, so that means like there's less stuff to them as you move farther away from the radiation zone. So let's get into talking about these layers. So you know that the corona layer is not really anything to do with the coronavirus. Move myself over again. So the core, that's going to be, and that is going to be the most center part, obviously. Just like the Earth has a core, this is kind of like the Earth's inner core. So this is the centralmost region, and this is where you are going to get your energy production from. This is where it is going to be turning. The most important thing that happens in the core is nuclear fusion. So that's going to be turning that into helium. So you have those 2 hydrogen atoms that fuse together, which means they join together, and then they form helium. During that production, you are going to release a lot of energy and a lot of heat. So this is where you have a lot of heat come in, like hotter than the Earth's core even, and then you have a lot of pressure because, again, this is the inner core of the Earth has the most pressure on it, same thing, with the sun. So the most important thing to take away from the core is that is where nuclear fusion goes on, and that is where the sun gets its energy. Nuclear fusion, hydrogen combined, helium, and that production. This would be better again if my slides would actually change. Then you go to the radiation zone, which is right outside the core, so it's kind of like the mantle of the Earth. But this is the radiation zone, and what happens there, this is where, oh, the dog just came in. He wants to say hi. Hi, Sunny. Okay. This is where you have gas is very tightly packed together, and it takes energy up to 100,000 years to actually move through this layer because it's so tightly packed and so dense. So it takes a long time for the energy to actually leave the core, move through that zone, and actually get all the way through it. So that's the radiation zone. And then the convection zone, you should be familiar with the word convection. This is where you have hot gases rising, and then they cool and they sink, and so you have that convection going on as well, which comes down here, cooler gases sink, forming loops, and then that eventually moves out to the sun's surface. So convection, we've talked about that many times, but you have hot gas rise, cool gas sinks, it gets heated up again, it rises, it cools, it sinks. So that's the outermost layer of the sun's interior. On top of this, we have the sun's atmosphere, which is going to have the 3 layers. So the first layer is called the photosphere. That's the one that is closest to the convection zone. Sorry, Glenn is now, licking my feet because that's normal. So the sun's surface is not solid. So it's not like if it were even cool enough, we'd go walking on the sun because it's a bunch of gases. It's just a big ball of burning gas. But when you look at a picture of the when you look at a picture of the sun, you're looking at the photosphere. So when you see a picture of the sun, never look directly at the sun. That's why I say picture. It's supposed to view the sun. But when you see the picture of the sun, that is going to be the photosphere. And the reason you can see it is because it's actually thick enough to see. I don't know why it doesn't like that. But it's thicker to see. So this is actually considered to be like the sun's surface layer. It's that first layer that's closest to the convection zone. That's going to be like the sun's surface, and it's called the photosphere. And that's what you see if you're looking at a picture of the sun. Above that, so we're moving up. So here you can see in this picture, we have the photosphere, which is right next to the convection zone, and then you have what we call the chromosphere. So the only time you're going to see the chromosphere is during an eclipse. And that we talked about last time, that is when the moon passes directly between the sun and the earth. And when you see an eclipse, it kind of has like this reddish glow around it that's happening during eclipse, and that's the chromosphere. And look at the temperatures on these things. Yay! Ain't nobody got time for 15 million degrees or even 6,000 degrees. Nope. And then finally, it's the corona. Nothing to do with the coronavirus. Kind of ironic that we are actually talking about it, since it is putting us at home and you now have to watch these videos instead of me teaching you. But this is also going to be seen during a solar eclipse. When that solar eclipse happens, when the moon passes directly in front of the sun, when it's completely blocking out the sun, right around the sun, it kind of looks like a white halo. So if you see pictures of a solar eclipse, it's going to be like a big black circle, and then there's a white halo looking thing around it. This can actually, the corona can actually extend millions of miles or kilometers, millions of kilometers into space. And part of the reason we have those solar is because of these particles from the corona, which is then going to give us those northern lights as well. So this can actually reach and charge particles far away and produce what we call solar winds. Then we have some fun things, features of the sun. Sunspots, those are dark areas of the sun. They kind of look like the sun's dirty. That's actually where the gas right there is actually cooler than the other gases around them. So they are not giving off as much light. So they can look extremely small because the sun is so far away from us, but these sunspots can be as large as the Earth. And the number of sunspots is going to vary, and it's going to change because that gas can change its temperature as well. So when you have the cooler gas region, it's going to appear darker, and you're going to get what we call a sunspot. I have some stuff in my face, but that's just because I digress. Prominences. Oh, I didn't see this, but it's a huge loop of like, and then connecting the dots, those will often connect sunspots. So when you have a prominence, sorry, dog is going crazy. When you have a prominence, that's typically going to be connecting two sunspots, which are the areas of the cycle. I was really excited about the sun. Okay, and then solar flares. So when you have, there's a little flare, but I was trying to look for a picture of it here. So when you have these loops, these prominences in the sunspot regions that they actually connect, they release a large amount of energy. It's like two electrical wires crossing and then boom, boom. So this energy heats that gas on the sun to millions of degrees Celsius, which is going to cause the boom when those two things connect. And these eruptions are called solar flares. So solar flare is kind of like a big eruption because you have those sunspot regions connect, those loops, those prominences connect, and then mind blown, sun blown. And then the solar wind. We talked about this earlier, and I briefly mentioned it, but when you have the solar wind, which is from the corona, when those particles enter the north and south poles, that's going to cause the northern lights, the aurora borealis. So those like greenish blue lights, you know, that's on my bucket list to see, I've never seen. That is actually from the solar wind. So those solar flares, they can actually cause an increase in solar winds, which is going, so that big solar flare is kind of like a little boost to actually go into the Earth's atmosphere, and then you are going to see those northern lights, the aurora borealis. So that's all we got on the sun. Hope you learned lots. Remember, the core is where the production of energy is by changing hydrogen to helium. Remember that. If you don't remember anything else, remember that. Then you want to say goodbye? You want to say goodbye? Bye-bye. Forward touch.